We're asked to calculate the density of a gas at STP. There's several methods to do this. I'll illustrate two. So let's look at method one. Method one, we can simply remember our equation that the density is equal to the pressure times the formula weight divided by RT. Okay, there's a lesson video where we talk about deriving this if you can't remember. Let's just plug and chug. At STP, our pressure is exactly 1 atmosphere. And our temperature is 273.15 K. We're going to divide by R, 0.08206. Units are liter atmospheres per mole Kelvin. And finally, we multiply by our formula weight, which for chlorine we can check our units to see how things are set up. And we see that the only units that survive are grams per liter, which are the appropriate units for the density of a gas. We'll go ahead and calculate our value here. This comes out to be 3.1631 units of grams per liter. We can go back and determine that we can justify 4 sig figs. Now remember, I made a note that I've written this with 3 sig figs, but this is an exact number because we're dealing with STP conditions. So we can go ahead and justify 4 sig figs for our final answer, 3.163 grams per liter. All right, this is one method of calculating a specific type of problem. We do have alternatives, and I'll give you one other. Likely you could find more, but let's look at this method. We'll remember that the standard molar volume of a gas is the same for any gas at STP. So we can calculate our value by the mass of 1 mole of the gas divided by the volume of 1 mole. The mass of 1 mole of gas is going to be the formula weight, which for chlorine is 70.90 grams per mole. And we're going to divide by the volume of 1 mole of a gas at STP. And again, we see our units are going to cancel out. So we have our calculator value in the end that's equal to 3.1631 grams per liter. And again, we get the same result as above. And we've showed you 2 methods. Undoubtedly, you can come up with more.